we are considering solid and liquid contact. At the point where a liquid is in contact with a solid, the surface of the liquid makes an angle with the solid. Okay, and the magnitude of this angle, the value of this angle, it depends on the relative magnitude of cohesive force and adhesive force. Okay, so I will now discuss angle of contact. Okay. Consider liquid in a pipe. Consider liquid in a pipe. These are the molecules of the liquid. These are the molecules of the liquid, and these are the molecules of the solid. These are the molecules of the solid. Okay, so both the cohesive force and adhesive force are in play. Okay, this is a molecule of the liquid. It is being attracted by the neighboring molecules, and that force is called cohesive force. This is a molecule of liquid. It is also in close contact with the molecules of solid, and force between these solid molecules and the liquid molecules is called adhesive force. Okay, so both the forces are in play. Okay, what is the, consider this molecule. Consider this molecule. What is the direction of net cohesive force acting on this molecule? Net cohesive force acting on this molecule. Not downward, it is being attracted in this direction. It is being attracted in this direction. It is being attracted in this direction. So the net, it is being attracted in this direction. It is also being attracted in this direction. It is being attracted in this direction. So if you consider the resultant will be in this direction. Is it clear that the net cohesive force has this direction? This is net cohesive force, FC. Is it clear? Now, net adhesive force. This molecule, this is the liquid molecule, this is being attracted by this in this direction, this is being attracted by this in this direction, this is being attracted by this in this direction, this is being attracted by this in this direction. So what will be the direction of the resultant? It will be this. This is the net adhesive force. Okay, so this is the net adhesive force, this is the net cohesive force, this is the solid. You may imagine this to be a pipe, glass pipe, and inside the glass pipe you may assume that you are having some water. So these are actually water molecules in that case, and these are actually glass molecules. Okay. So, but this is generally it is applicable to all types of liquid molecules and all types of solid molecules. Okay. So now, which force is greater, FC or FA? It depends on material. It depends purely on material. Okay, whether you have water here, or you have mercury here, or you have oil here. Cohesive force depends on the substance of the liquid. Okay, and adhesive force depends on what? Adhesive force depends on both. Adhesive force depends on the substance of liquid and substance of solid. Okay, for a given pair of solid and liquid, adhesive force is fixed. Suppose for glass and mercury, adhesive force is fixed. But if you consider water and glass, the adhesive force will be different. Okay, so remember, for a pair of substances, for a pair of solid and liquid, adhesive force is fixed. Okay. Now, in order to find the resultant force acting on this molecule, first resolve Fc into two components. Resolve Fc into two components. These are the components. This is Fc by root 2, because this angle is 45 degree, and this is also Fc by root 2. This angle is 45 degree. Okay. Now consider this molecule. Consider this molecule separately outside. What are the forces acting on it? Fa, Fc by root 2, another Fc by root 2. We are, for the time being, we are ignoring the weight of the molecule. Gravitational force we are ignoring. We are considering only the adhesive and cohesive forces. These are the forces. For some liquid and solid, I have already told you that adhesive force depends on the pair, solid-liquid pair. If Fa is greater than Fc by root 2, that is case 1. That means solid and liquid as such that Fa if Fa is greater than Fc by root 2, then what will happen? If Fa is greater than Fc by root 2, then the resultant force will be in this direction. This is Fa minus Fc by root 2, and in this direction you have a force Fc by root 2. So these two forces will have a resultant in this direction. So this is the direction of the net force acting on this molecule. Okay? This is the direction of the net force acting on this molecule, and accordingly the surface, the liquid surface will be like this. Because this net force, because the surface is always perpendicular to the net force. That is because if this molecule has other molecules in its surrounding, they will exert normal force on this in order to balance this. Okay, the surrounding molecules will exert normal force on this. You consider the molecule which is just below, which is just in the line of this resultant force. In order to balance this force, what will this molecule do? This will exert a normal force on this, and if this be the normal force, what will be the nature of what will be the shape of the surface? All of you know that normal force is always perpendicular to the surface. Okay, so first this particular molecule, go step by step. This particular molecule, we have assumed that Fa is greater than Fc by root 2. In that case, the resultant will be in this direction. So on this particular liquid molecule, the net force is in this direction. Okay, now consider the molecule which is in contact with this and in the line of the resultant force. In order to balance this force, this molecule will exert a normal force. So this is the normal force, and we know that normal force is always perpendicular to the surface. So what will be the shape of the surface? I have shown the shape of the surface. Okay, so if FA is greater than FC by root 2, then you will get, there is a pipe. Now consider a pipe. Inside the pipe, the surface of the liquid will be this. Okay, surface of the liquid will have this shape. Is it clear to all of you? Have you understood? Now we will go to case 2. In case 2, FC by root 2 will be greater than FA. In case 2, FC by root 2 is greater than FA. In that case, this is the molecule of the liquid. FC by root 2 is greater than FA. So in this direction, there is a net force. FC by root 2 minus FA. In this direction, there is another force, FC by root 2. So the resultant will be this is the resultant force. Okay. Now consider a molecule just below this and in the line of the resultant force. This molecule, in order to balance this molecule will exert a normal force in this direction. Okay. And we know that surface is always, a normal force is always perpendicular to the surface. So the surface will be like this. The surface, this will be the shape of the surface. Okay. So in which case do you get this type of surface? Provided FC by root 2 is greater than FA. Now consider mercury. For mercury, cohesive force is too much. So for mercury and glass, you will get this type of surface. Previously I have illustrated water and glass. Now, for mercury and glass, you will get this type of surface. This is glass. This is mercury. For mercury and glass, we get this type of surface. Okay. And there may be another case, case 3, in which FA and FC by root 2, they become equal to each other. In that case, you will get a flat surface. Flat. Okay. So case 3, in case 3, FA equal to FC by root 2. If FA equal to FC by root 2, on this molecule, there will be only one force, FC by root 2. And the molecule which is in contact with this and in the line of this force will exert normal force. In this direction. Okay. As a result, the surface will be like this. Flat surface. Okay. So consider this. You are getting this type of surface. Okay. And there is a particular pair of solid and liquid that gives you this type of surface. It is silver and pure water. Okay, silver and pure water. This is silver pipe, and if you use pure water, you will get this type of surface. Okay, so I have discussed the interaction of the effect of adhesive force and cohesive force when they act together on a liquid molecule. Okay, and the result is the different shape of liquid surface. In some case the liquid surface becomes like this, in some case the liquid surface becomes like this, in some case the liquid becomes like this. Okay, so then angle, what is angle of contact? Angle of contact is this angle consider these three cases. Consider these two cases because that is exceptional, flat surface. In the case of water and glass, okay, that is an example, water and glass. You may have other solid and other liquid also. This is called, this free surface of liquid is called meniscus. This is a pipe, this is the pipe, this is the meniscus. Draw, the meniscus is in this form. Okay, the meniscus is in the form of a bowl. This is the meniscus. Draw a tangent to the meniscus. Draw a tangent to the meniscus at the point where it touches the pipe. Okay, or where it touches the solid. Draw a tangent to the meniscus at the point where it touches the pipe. Okay, so this is the tangent. We have drawn this tangent at the point where the meniscus, you have understood meniscus, the free surface. At the point where it touches the solid, I have drawn a tangent. The angle made by this tangent with the surface of the solid, with the surface of the pipe, and such angle being inside the liquid. Okay, this is the tangent. You may consider this angle. This is not inside the pipe. This is not inside the liquid. You may consider this angle. This is inside the liquid. So angle made by this tangent with the surface of the solid and such angle being inside the liquid is called angle of contact. Okay, so this is angle of contact. Okay, so this is angle of contact. In another case, this is another case. As an example, you may consider mercury and glass. This is the meniscus. This is the meniscus. Draw a tangent to the meniscus at the point. Draw a tangent to the meniscus at the point where it touches the surface of the solid or surface of the pipe. Then angle made by this tangent with the surface of the solid, surface of the pipe, and such angle being inside the liquid is called angle of contact. So this angle is being inside the liquid, this is angle of contact. This is angle of contact. Okay. So angle of contact definition may come in exams, so write it. A tangent is drawn to the meniscus. A tangent is drawn to the meniscus at the point where it touches, the surface of the capillary. The angle made by this tangent, with the surface of the capillary, angle made by this tangent with the surface of the capillary, and such angle being inside the liquid, is called the angle of contact. Okay? For liquids, right? For liquids that weight the surface of solid, for liquids that weight WET, for liquids that weight the surface of solid, the angle of contact is acute. The angle of contact is acute, and for liquids that do not weight, the surface of solid, this angle is obtuse. This angle is obtuse. For example, for glass and water, angle of contact equal to very close to 0 degree, and for mercury and glass, this angle is 139 degree.